Welcome to section 2.2, Measures of Variability. In the last section, we focused on finding the center of a data set, the mean, median, or mode. But now we're asking a different question. How spread out are the values? That's what variability tells us. In this lesson, we'll explore why spread matters and how to measure it using the range, variance, and standard deviation. Two data sets might have the exact same average, but behave very differently. One might have values tightly packed around the center, like the larger distribution here, right? Notice a bunch of the values are right in the center here. The other might be scattered more widely. We have more values over here and over here on this smaller distribution, right? Understanding variability helps us evaluate how consistent or volatile the data is, which is essential for risk, quality control, and decision-making. For example, imagine two employees both average 8 hours of a workday, but one always works exactly 8 hours, while the other works 4 hours one day and 12 hours the next day. It's the same mean, but very different experiences. That's the power of measuring spread. Now, the range is the simplest measure of variability. It's just the difference between the largest and smallest values in the data set. So your formula for range is just the max minus the min. It gives you a quick idea of how wide your data is spread, but it's also fragile. A single outlier can dramatically change the range. For example, if 24 students score between 70 and 90 on a test, but one student scores a 30, the range becomes 60, which doesn't reflect the majority of the group. So while the range is easy to compute, it's not the most reliable tool. To get a more reliable measure of variability, we use variance. Variance tells us on average how far each data point is from the mean, but it does so by squaring each deviation. This keeps all distances positive and gives us greater weight to larger differences. So, the formulas. Sample variance, you're just taking your data point minus the mean, square it, and then do that for the next data point and the next and the next, and add them all up, right? That's what the sigma means, add them all up. Then divide by one less than the number in the sample. Population variance, and by the way, we use S squared for the sample variance. We use lowercase sigma squared for the population variance. Same basic formula, data point minus mean squared, and then add them all up, then divide by the number in the sample. I'm sorry, the population. That's the difference between the population and the sample formulas, right? N, you're dividing by the number in the population to get the population variance. And in minus 1, you're dividing by the number minus 1, okay? So the sigma symbol means we're adding up all the squared differences between each value and the mean. We then divide by n minus 1 for a sample or by n for the full population. Keep in mind, variance is in squared units. So if your data is in dollars, your variance is dollars squared, which is hard to interpret. That's where standard deviation helps. The standard deviation is the most widely used measure of variability. It tells us the typical distance of values from the mean. And unlike the variance, it's in the same units as the original data. It's simply the square root of the variance. Here are the formulas. So to get the sample standard deviation, lowercase s, just take the square root of the variance. For the population, lowercase sigma is the variance, is the standard deviation, take the square root of the variance. If your standard deviation is 5, that means values typically vary about 5 units from the mean. In real life, you might say, on average, most salaries are about $5,000 away from the mean. That's information you can work with. So what does a small or large standard deviation tell us? A small standard deviation means values are closely clustered around the mean. The data is consistent. A large standard deviation means the values are spread out. You might have big highs and lows. Imagine two pizza delivery chains. Both claim average delivery times of 30 minutes, but one has a standard deviation of 3 minutes while the other has a standard deviation of 15 minutes. One is consistent. The other might be fast one day and an hour late the next. Even though the averages are the same, the reliability is very different. All right, let's review some quick facts about standard deviation. Standard deviation is never negative. If standard deviation is 0, it means every value in the data set is the same. The greater the spread, the larger the standard deviation. Standard deviation is more informative than the range and is preferred in most real-world comparisons. If you remember one thing, standard deviation gives you a reliable sense of how typical or unusual any single value is within a data set. All right, let's revisit the exam scores data from the last video and explore how spread out those scores are. Let's start by calculating the range. So let's go to the data set. All right, there we go. All right, so we want to start with the range. It's just subtracting the smallest from the largest. So to get the range, we can do the max value, A2 through A26, minus the min value. To get the variance, we can do equals var dot s for the variance of the sample, A2 through A26. And the standard deviation, we can do one of two ways, right? We can do standard deviation dot sample, A2 through A26. Or notice if I just do square root of D7, it should give me the exact same value. Now, notice how much the value spread out from the average. In this data set, our outlier, the low test score, increases the standard deviation and the variance. This is a good reminder that standard deviation is influenced by extreme values. It reflects not just the middle of the data, but the extremes as well. These tools in Excel make it easy to summarize variation and give you a deeper understanding of what a data set is really telling you.